So let's start with the second question from our object-oriented programming video series. Can you define object-oriented programming and the four principles associated with object-oriented programming? Now this video is a theoretical video and we have divided this video into three parts. The first part, which basically talks about the definition of object-oriented programming. In the second part, we talk about that how object-oriented programming resolves the problem which functional programming had. So in our previous video we had discussed about the four problems associated with functional programming, that is reusability, extensibility, simplicity and maintainability. So in the second section we will see that how object-oriented programming solves those four problems. And finally we try to understand the four important principles of object-oriented programming, and these principles are later discussed in the coming up videos in more details. So let's first define object-oriented programming. Object-oriented programming is a design approach where we think in terms of objects, rather than thinking in terms of functions. So rather than thinking in terms of functions like function 1, function 2 or something like technical functions, we try to think in terms of real-time objects, real-world objects. Let me try to explain you what that means. So rather than thinking in terms of calculate cost, or rather than thinking in terms of function like calculate cost, interest, what we do is that we create objects like product object, or we create object like product with discount objects. Now the time we start thinking in terms of objects, we come near to the real world more, and our code becomes more maintainable. So that's a basic definition of object-oriented programming, that it's a design approach where we think in terms of real world objects, rather than thinking in terms of technical functions. So as we have discussed in our previous video, where we talked about the four different issues with functional programming. Now let's try to understand that how object-oriented programming helps us to resolve these four problems. So let's start with the first one, that is reusability. Now in order to address reusability, object-oriented programming has provided something called as classes and objects. So rather than copy pasting the same code in different UIs or in different location, what you can do is that you can create a class and then make instances of the classes, which is called as objects, and reuse them wherever you want. Now the objects which are created of the classes, right, or the instances which are created of the classes are created in memory. So the code isn't copied again and again in physical files. So in other words, you have less redundant code and you have higher reusability. Now the second problem with object-oriented programming was extensibility. So in other words, you have a function and you want to extend it with new features. That was not possible. So you have to make a complete new function and then change the whole function into whatever you want. In object-oriented programming, this problem of extensibility is solved by using inheritance, aggregation and composition. We will be discussing about all these features in the coming up videos, but at this moment just try to at least understand the terms which help to solve the functional programming problem. So object-oriented programming provides inheritance. So in other words, you can have a function, you can inherit that function and then make tailored changes to it. In other words, you have a function, you can just use that function and then apply some extra layer on that, which is called as aggregation or composition, and change the behavior of it. So in other words, you can extend the current functionality using object-oriented programming by using inheritance, aggregation and composition. The third problem associated with functional programming was simplicity. So because of reusability and extensibility, you end up with a lot of functions, you end up with a lot of scattered code, different method names, different functions. So object-oriented programming has addressed this issue by providing three important properties. One is abstraction, encapsulation and polymorphism. We'll come to this step by step in the coming up videos, but at this moment, as I've already mentioned, that we are trying to map the problem and we are trying to see that what object-oriented programming has given in order to solve the problem. So in order to make your method simple, object-oriented programming has provided abstraction, encapsulation and polymorphism. And overall, because we address reusability, simplicity and extensibility, we have good maintainable code, we have clean code, and with that, the maintainability increases. So in this way, object-oriented programming provides solution to the four basic problems associated with functional programming. So let's sum up. So now if we try to sum up with whatever discussion we had, we talked about the various problems, how object-oriented programming basically solves the various functional programming problems. We sum up with four important characteristic of object-oriented programming. First one is abstraction, second one is encapsulation, third polymorphism, and fourth inheritance. So let's try to understand these four properties, and we'll then in the coming up videos, what we'll do is that we'll take up one property and we'll see that how actually in source code these properties look like. So before we go ahead and we talk about all these properties, all the 4 properties, you can remember these 4 properties by the word API. So A for abstraction, P for polymorphism, I for inheritance, and E for encapsulation. So let's first start with abstraction. Now abstraction basically allows to simplify a complex object. For example, let's say that I can tell you about colors, like I can say that okay, I have made a component of colors, and what, it gives you reddish green, it gives you bluish white, it gives you whitish brown, brownish white, it gives you a mixture of white and brown and red. So rather than, what I will say is that give me what values of RGB are you talking about. So with that, what has happened is, rather than giving him 1000 different colors and 1000 different combinations of colors, I can just give him RGB, which basically abstracts any kind of color in the world. So in other words, abstraction allows you to simplify your component or simplify your object, which needs to be interact with the outer world. Because remember that one of the very important principle of object oriented programming is to have simplified interfaces. Okay, so again, just redefining abstraction or just revising abstraction definition, it allows you to show only the necessary properties, and with that your object is no more complex, it is more simplified. So abstraction basically means show only the necessary properties.